Hi, I'm Ms Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. All right, so now we're going to find the derivative of y equals the natural log of x. And we're going to do this using implicit differentiation. So what I mean by that is we're going to start by taking y equals the natural log of x, which we don't know how to find the derivative of, and we're going to rewrite it in what's called its exponential form instead of logarithmic form, because we know how to take the derivatives of certain exponential functions. So remember that natural log is what? Log base what? There's going to be an x, but what's the base here that's implied by the notation natural log? Natural log is log base what? Not 10, that's the common log. That's when you, like, if you have a log of 1,000, that's the same as log base 10 of 10,000. That's the common log, base 10, but I'm talking about the natural log. Very good. E is the base of the natural log. Does anyone know approximately what value E has? The number E? Good. It's about 2.71, 2.72, somewhere in there. All right, so I'm first going to rewrite it so I can see the base. Now let's convert this to exponential form. What is this saying? This is saying that y is the power to which we raise e to get x. Y is the missing power. So we're going to rewrite this as x equals e to the y power, right? Y the power to which we raise the number e to get x. All right, so this, by the way, is going back and forth between logarithmic notation and exponential notation, that relationship up there. All right, so now what we're going to do is remember our goal. Our goal is to find the derivative of y equals natural log of x. So we're looking for dy dx, in other words. So we're going to use implicit differentiation to find that derivative. So I'm going to differentiate on both sides with respect to what variable? X. Good. So we're going to take d dx of both sides of this equation. Okay. So on the left, we're going to just get 1. The derivative of x with respect to x is 1. On the right, we have e to a power. So we're using the rule derivative with respect to x of e to the x, recall, is just e to the x. But the variables match up. So what you have to do when this variable inside your function doesn't match up with the variable you're differentiating with respect to. That's right, you're going to need to throw a dy dx in there, right? You're going to differentiate like you normally would, so e to the y. But since it's not an x, you're going to have to multiply times dy dx. Okay, so now I'm going to solve for dy dx, so dividing both sides by e to the y. So dy dx equals 1 over e to the y. But we don't normally like to have our derivatives written in terms of y if we don't have to. We'd prefer to have them written in terms of x. Does anyone have any suggestions as to how I could go about rewriting this as an equivalent expression that has x's in it instead of y? No, we've already differentiated. We're not going to differentiate again. Okay, what about ln? Remember, y at the beginning was equal to the natural log of x. That hasn't changed. It's still equal to the natural log of x. So we can actually replace y with what it's equal to. Y is actually the same thing as the natural log of x. So that means that dy dx is equal to 1 over e to the power of the natural log of x. Very good. All right, so, but that can be simplified, can't it? Let's go off to the side here. Let's see if we can remember, how can we simplify e to the power of the natural log of x? Yes, it is just x. Very good. So you're raising e to the power of log base b of x, log base e of x. This, whenever the bases are the same, you can think of it as them canceling out. Again, in my videos, I'll explain why, but for today, we're going to just say that's just equal to x. Okay, so the derivative of y with respect to x, when you start with y equals the natural log of x, we got 1 over x. So we now have a new rule. We have the rule for the derivative of the natural log. So the derivative of the natural log, well, this is written in u notation. In x notation, the new rule we have is the derivative with respect to x of the natural log of x is equal to 1 over x. Okay, remember all this u notation is it incorporates the chain rule into the notation. So what we're saying is if you take the derivative with respect to x of the natural log of any function u, that's going to be 1 over that function, 1 over u, times the derivative of that function with respect to x. It incorporates the chain rule right into the formula. It's not necessary because we know the chain rule, but a lot of times the books give you that version of the formula just as a more general formula. All right, so let's try to apply this idea. We're going to find the derivative of y with respect to the independent variable, which in this case is x. So we're looking for dy dx, which is what we're going to do in the next video. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.